Welcome to this other lesson of A Level of Physics, Paper 2 at Back Science Education Consultants. I'm Teacher Course. In the previous lesson, we are looking at the arrangement of capacitors and then the effective capacitance. And we found out that when capacitors are arranged in series, then the effective capacitance is given by following this expression, that 1 over C is 1 over C1 plus 1 over C2 plus 1 over C3, and if there are any capacitors up to all of them. And then, how are they in series? If the same current would pass through those capacitors, then those capacitors are in series. If the current passing through them is not the same, then they are in parallel. You have to get that point, because for future reference it will be needed. Okay? And then we found that this was for the series arrangement, and then we said that if it is for the parallel kind of arrangement, then the capacitance, it is just the addition of, you just add all the capacitances of the different capacitors. So by doing so, you are able to do what? To get the effective capacitance. Now today, we want to apply that one in calculations. We did some example. Now we can add on other examples so that it can bring a more understanding. And we are just beginning, and feel free to write that in the figure below, two capacitors of capacitances C1 and C2 of 3 microfarads and 6 microfarads respectively are connected across a 90 V DC, a 90 voltage DC. Calculate the charge on C1 and C2 and the PD across each. Calculate the charge on C1 and C2 and the PD across each. So what are we given and what is needed? The diagram is right here. This is the diagram. This is the C1, this is the C2, this is the DC supply. This is 2 microfarads, 6 microfarads. This is 90 volts. Now, I may ask, are these two capacitors in series or in parallel arrangement? Tell me, are they in series or in parallel? Say it. Are they in series or in parallel? Oh, you have it. Yes, they are in series. Why? Exactly what you are thinking about, that you feel you should not say it because I will not hear it. I'm hearing it and I can again hear it. Yes, you can also hear it on my behalf in case you think I cannot hear it. Please say it. Because if the current starts flowing like this, it will continue. The same current that passes through this capacitor C1 will pass through this capacitor C2. Okay? Therefore, the same current passes through both, and they are in series arrangement. And we said in series arrangement, how do we get the capacitance? They are just two. So we derived an expression that if there are two, then the capacitance will be the product out of sum. And therefore this gives us 2 times 6, then out of 2 plus 6. 2 times 6 gives us 12 volts. Okay? Then did I? Yes, 2 times 6 gives us, I think the question said 3 microfarads. This one is 3. Yes. So this is 3. So it is 3 times 6 out of 3 plus 6. So this is 18 out of 9. And then it is 2 microfarads. Meaning that this arrangement is the same as if somebody has this arrangement of 2 microfarads and then just have like this 90 volts. This arrangement is the same as this because the effective capacitance of these two arranged together, it gives us the 2 microfarads. So what does the question want? The question says that calculate the charge on each of the capacitors. So before you get the charge, you must first get the effective capacitance, okay? And then from the charge is CV, then we can get anything because we have the voltage, we have this one, okay? So you can get the charge. Now, this charge will be the total charge on all the capacitors, okay? On an equivalent capacitor. So therefore, that charge equals the capacitance is 2, a micro is exponent negative 6, then times 90, and when you check, you'll get 1.8 exponent negative 4 coulombs. 1.8 exponent negative 4 coulombs as the total charge on both the capacitors. But what does that one tell us? It gives us a load. Because what is the charge stored on this capacitor and then charge stored on that capacitor? These two capacitors are in series. And remember, we said that when capacitors are in series, they store the same charge. So the charge on this capacitor is equal to the charge on this capacitor and is equal to the total charge. Therefore, that one tells us that the charge stored by this is this coulombs and the charge stored by this is that coulombs, the same. Since they are the only ones in the circuit and then the total charge is that, then each of them stores the same amount of what? The same amount of charge. We are presented with another question that was the charge on each and the PD across each. So how do we get the PD? You realize that since they are in series, then the PD across them is not similar, but the PD across this plus the PD across this will be equal to the separate PD. Okay? So therefore, from the expression, this one, that 2 is CV, V is 2 out of C. Okay? So you can say V across this one, if we call it V1, V across C1, if we call it V1, will be 2, 1 out of C1. But 2, 1 is the same charge as the overall charge. So which is 1.8 exponent negative 4 out of C1, 3 exponent negative 6. And when you press on the calculator, it is supposed to give you 60 volts. That is the V across this one. What's then the V across this one? It is as simple as get this, subtract the V across that. You get this. So we should actually be giving you 90 minus 60. It should give you 30. Or alternatively, you also say that V2 is 2 out of C2. The same 2 is the same 1.8 exponent negative 4. Then C2 is 6 exponent negative 6. And this gives us, when you press on the calculator very well, press on the calculator, press so that you confirm, you get 30 volts. So that is the voltage across each of the two capacitors. Don't forget to subscribe to Backscience Education Consultants. That is how we get the charge and then the voltage across. We shall of course learn even more. Okay? We'll continue moving. We want to have yet another question. But before that, whenever you are given any calculation on capacitors, you must make sure you begin by calculating the effective capacitance. That's the password. There is no any other password except that. Okay? Okay, you get it well? Thank you very much. Let's have another question. Let's have another question. So you could pause. You could pause and have your time on that. I think the pausing stops here. Okay? You can pause and do that. Then after, you move on. You are in control. We are in digital world. It's you. It's not me. It's you now doing this. Okay? So we can have yet another question. When I grab this, which you have paused and done all that you want. So we have another question. And the question presented to us, it is saying that calculate the charge on the capacitors below and the PD across each. That they calculate the charge on the capacitors below and PD across each. And these are our capacitors. We have that. We have this. We have this. This is 120 volts, 4 microfarads, 2 microfarads, and 3 microfarads. You could name them C1, maybe C2, and C3. Okay? So the question says that calculate the charge on the capacitors and the PD across each. So we have to get the effective capacitance. What do we do first? I said we first look for which ones are in series, which one is in parallel, then how do I handle them? Okay? For instance, you cannot say that this one is in series now with this, then you first say this one is in series with this, then is in series with that. No. You see, these ones are so close to each other, so you can first handle these ones. Okay? So you see that C2 and C3 are in parallel arrangement, meaning the effective capacitance of C1, of C2 and C3, the C2 and C3, they will give us the effective capacitance of this. Since they are in parallel, then we sum up. So you shall have 2 microfarads, then we add 4 microfarads, and this will give us 6 microfarads. And after doing this one, you would have a diagram that looks like this. This is 3 microfarads, and then the whole of that is 6 microfarads. Then this is 120 volts. So what is the effective of these two? These are in series. So therefore, the effective of this will be the product out of sum. This will be 18 out of 9, and this will give us 2 microfarads. So now, the whole of this arrangement, the effective capacitance of this arrangement is actually 2 microfarads. This is similar to an arrangement which has this capacitor, just this capacitor of 2 microfarads, and is connected across 120 volts. Is connected across 120 volts, and we want the charge and the watt. So how do we do it? Can we get the total charge stored? Total charge is CV, you know that, and capacitance is 2 exponent negative 6, then V is 120. And when you perform the calculation, the 2 then 120 gives you 2.4 exponent negative 4. This should give you 2.4 exponent negative 4 coulombs. It should give you 2.4 exponent negative 4 coulombs. And then the question, of course, is saying calculate the charge on each of the capacitors. So this is the total charge, but we want charge on each of the capacitors. So we shall go back slowly. This is the total charge. From this, I can go back to that arrangement, meaning that the charge stored on this is equal to the charge stored on this and is equal to the overall charge. Okay? Meaning the charge on 3 microfarad and the charge on the 6, meaning the charge on both these ones is this, and the charge on this one is this. So I can say the charge 1, if that's the charge on capacitance on C1, is this one. Okay? So is 2.4 exponent -4 coulombs. What about charge 2? You realize that this and this, now there you have to add the charge on this plus the charge on this equals this charge that is on this 6, right? Yes. The charge on this plus the charge on this. So I can say that the charge 2 plus the charge 3 is equivalent to this one, 2.4 exponent -4. Are you there? Yes. Charge 2 plus charge 3 is equal to that. Then how will I get now the required charge? Okay? What is charge 2? What is charge 3? Charge is CV. But what I know is that the V across this one is equal to the V across this one and is equal to actually that. Right? So I can also use that information. I can use that information very well. And I can say that V2 is equal to V3. But what is V2? V2 is charge 2 over C2. This is charge 3 over C3. So I can say from there, this is Q2 over C2. Let me first write. Equals Q3 over C3, which gives us Q2 out of C2, which is 2, equivalent to Q3 out of C3, which is 4. Cross multiply this 4 here, this 2 there, and when you cancel by 2, 1, by 2, 2. So the 2 Q3 is equaling to 2 Q2 is equaling to Q3. So when we do that, now when I bring this one and substitute in this one, I have the capacity to get all that I want. Therefore, Q2 plus Q3, which is 2 Q2, is equivalent to 2 exponent -4. So this is 3 Q2 is 2 exponent -4. And therefore, the charge 2, it's just got by getting 2 exponent, it is actually 2.4. It's 2.4 exponent -4, then divide by 2.4 exponent -4, then divide by 3. That one should give you 8 exponent -5. That one should be giving you 8 exponent -5 coulombs. Then that means you can get Q3, which is 2 times 2. Okay, so 2 times that. Eight. That is 8 exponent -5 minus 2. 1.6 exponent -4. So the Q3 will be 1.6 exponent -4 coulombs. I guess you are getting the same values as the ones that I'm actually getting. Then the other question that we want the charge on each of the capacitor. So at least we have got the Q1, the Q2, and the Q3. Now we can go to the PD across each. The PD across each. So how do we get the PD across each? The PD across each is got by using the same formula that we have used. So what is the PD across this? The PD across this and across that. Okay? We can even use this one. This one is equal to that. So the PD across this is equal to the PD across that. And when you add this one to that, it gives you this one. Okay? So we can now say that the PD across each of them, okay? For example, we can begin with this one, also 3 microfarad capacitor. V, can call it 1 since it was C1. So what is V1? V is 2 out of C. So it's 2 1 out of C1. And that one becomes, the 2 1 is 2 exponent the 2.4 exponent -4. Then the C1 is 3 exponent -6. So when you press that one on the calculator, what do you get? 2 exponent -4 divided by 3 exponent -6. This is 2.4 exponent -4 divided by 3 exponent -6. It should be giving you something like 80 volts. Yes, so this one gives you 80 volts. And then the V across this and this, the V across this and this other V across C2 and C3 is the same. I can get 180 and 120, I subtract that. And this one will give me 40 volts. So that is the V that is across these other 2 capacitors. All the understanding is found nowhere except at back science education consultants. I have some other, we shall give you some other calculation in the next video, and even more and more and more and more, and even give you the exercise. So please feel free to remain updated on our YouTube channel. Send our link to all the students that you know, so that they can also benefit from this. Otherwise, thank you for attending our lessons, and we pray that may you be blessed. That is it for now. Let's wait for, once again, another calculation. Just after this video, watch the next, because they are following each other. After the video, watch next and follow as you get other calculations, as we plan to come to an end of this chapter.